so once again, this is a graph of the derivative. So these are the things. Now what's written, these things written here are telling us things about the original function, okay? There was an absolute minimum that occurred at A on the original graph. Here's how we know that. This derivative is above the x-axis the entire time, which means, or it sometimes does hit 0 here, but if the derivative is positive the entire time after A, that means the graph is sloping up. So on the original graph, if the derivative this whole time is positive, don't I know then that the graph was increasing after A? This would have to be an absolute minimum, okay, where it occurs. Yeah. All right, now, do you see that here I said the derivative is positive, so what's happening on the original function? The function is going up. Now, I'm sorry. This is f of x. Okay. My bad. This is f of x. Here I'm telling you what's happening. Okay, so let me go back. So f prime of x is greater than 0. Do you see how the function is now increasing? F prime equals 0 levels off. F prime is greater than 0. Okay, so when we see that there is no change here, so derivative is positive, derivative is 0, derivative is positive, do you see how there's no extrema still? So is it possible to have a critical number, meaning the derivative equals 0 and not have an extrema? Yes. When? When this doesn't change sign. Okay? Let's go up to here. Positive then switches to negative. The derivative is 0. Do you see how that's a local maximum on f of x? Okay. Now, because the function is going down, the derivative would have to be negative. And then here it switches to positive. Do you see that there's a local min there? Okay. Hey, this is still a max. Is the derivative 0 here, though? This is a cusp, isn't it? And so what we would see is that the derivative would be undefined there. Something sloping down, derivative is negative. Something 0, but there's no sign change, so it's no extrema. Okay? All right, let's take a look then at the next thing, and this just kind of gives us a checklist that we're looking for. So today when you're doing problems and you're thinking, how do I decide this? How do I decide? So at a critical point, okay, if f prime changes sign from positive to negative, then f has a local maximum there. If f prime changes sign from negative to positive, what that means is negative means the function's going down to positive. What occurs? A local minimum. If the function doesn't change sign, so watch what happens. So the function, let's say, was increasing. Its slope goes to 0 for 1 point, but still increasing. Is that an extrema? So if f prime does not change sign at c, then f has no local extrema there. Now let's talk about absolute extrema. Basically, this is where it comes into play. Remember how I said on a closed interval, what should you do to check for absolute extrema? You also have to test what? The end point. Okay? And so this is why you can tell if a derivative is negative after the left endpoint the entire time, then that was a local maximum. Because what that means is it started here, the function sloped down the entire time. So that was the high point of the graph. But let's say we had the function and we knew the derivative was positive after that, then that function was going up, so then it would be an absolute minimum in that case. Okay. But that's why we have to test the endpoints. So if we have the original function, we can just make sure we test them. Because it's possible sometimes the derivative does both things, and that's how can we tell? We know it went up and down. How far did it go up? How far did it go down? So we need to test those endpoints for absolute extremes. All right. Let's see how this works then. This is where I put into play sign charts. And here's what AP would say about sign chart. A sign chart in itself is not justification, but a sign chart can help you lead to the justification. So what I'm going to do is I'm going to treat this as if this were an AP question, and then I'm going to answer it in that way, and then I'll justify my answer, okay? So basically what we have to do is we have to figure out where is the function positive and where is the function negative. So we first have to figure out where the derivative is either equal to 0 or undefined, because didn't I say find the critical numbers? Okay. Is the function undefined at all? Nope, because there's no fraction on the bottom. So then we're going to stick to the 0. So what would it be? 2x plus 8 equals 0. 2x equals negative 8. X equals negative 4. So now let's decide, if I was doing a sign chart, we did these in pre-calculus, we would want to put the zeros on there. Sometimes, lots of times there's more than one. This one, to start with, we're going to just do the 1. It's negative 4. What if I put negative 4 in, if I put negative 5 in, something over here? Nope, sorry, over here. What happens? Just tell me, is it positive or negative? Negative, okay. If I put 0 in, that's an easy one, right? Okay, so here's how we summarize. There's 2 intervals then. We have negative infinity to negative 4 is one interval. And the derivative was what kind of number? Negative or positive? So we write that like this. Less than 0 means negative, right? Tell me what that means about the function. It's decreasing. Then we have a second interval. We're actually not going to need our third. Sometimes I put tables on there in case, like if there were several zeros, I would need a third table or a third column as well to put them all on. You're going to see in the next one we do. Okay. What's my other interval? It's negative 4 to infinity. And then the derivative is positive, so we write the derivative is greater than 0. The function is now increasing. So, can you identify for me then a relative extrema? Where does it occur? -4. At -4, because that's the critical number. But what told me the function switches from decreasing to increasing? So this is how we would justify this in an AP test. X equals 4 is where a minimum, thank you, is where a minimum occurs because f prime of x switches from negative to positive. You would want to mention what the derivative does because it's the calculus thing. So that's what the justification is, but do you see how our chart helped us notice that? We wouldn't have really been able to do that without a chart. It just helps us organize it. That's where it occurs. So what is the actual minimum? How would I find it? I would actually plug -4 into the function. So -4, if I plugged it in, would be -4